Hey class, today we're going to be talking about ordering and comparing real numbers. Before we get into the ordering and comparing part, there are a couple just clarifications we need to make when it comes to these things. Um, so real numbers end up being your fractions, your decimals, and percents, but you might also see some other forms that you might have seen last year, such as absolute value. That's one of the ways you might see it, an absolute value. So remember, absolute value is the distance a number is from 0. It's always going to be positive, right? There's no negative distances. It's always positive. The absolute value of -9 would be +9. Another thing we might see is scientific notation. Very useful for us to use scientific notation when we're talking about really big things or really small things. So when we're doing scientific notation, it's really important for you to look at your exponent. So if your exponent is positive, you're going to move your decimal that many spaces to the right. And if it's negative, you'll go backwards and move it to the left. That also means we might have to change from standard form into scientific notation, which means it's kind of backwards. If we're taking our number and moving to the right, our exponent is negative. And then again, if we move to the left, it's going to be positive. I'm going to do a couple of these with you. I don't want to do all of them because I think once we get one, we'll kind of get our memories jogged. But say we have this number 7.028 times 10 to the 4th. First I'm going to rewrite the number just so I have it over here. And then I'm going to look at the exponent. I was supposed to circle the 4 there. And it tells me I'm going to take the number 4. Actually, I think it was -4. No, it's +4. I'm going to take my 4, and that tells me I take my decimal place and go 1, 2, 3, 4 spaces to the right, which means my next number ends up actually being 70,280. Same thing works with negative numbers. In this case, I have a negative exponent. So I'm going to take my number. Remember, if it's a whole number, I'm going to start with my decimal right afterwards. And because it's negative, I'm going to count 1, 2, 3 spaces backwards. And I end up with this number 0.006 or 600ths. I'm just going to do one of these next ones just because it is helpful to know how to go forwards and backwards. So when I have scientific notation, again, I'm trying to make a number that looks like here or here, right? I'm doing some factor times 10 to the whatever. So I'm going to take my decimal and I'm going to move it, and I'm going to try to get it to be in between the 1 and the 2 here. So 1, 2, 3, 4, 5, 6. So my number is going to look like 1.25 times 10 to the 6th. We might even see some inequalities. So an inequality is a mathematical sentence that displays quantities that are not equal. So you might see the less than symbol, like let's say 2 is less than 3. You might see your greater than, so maybe like 10 is greater than 0. You might see less than or equal to, or greater than or equal to. So again, those are used in those situations where they could be equal. They don't have to be, but they could be. I mean, we could go back to this. 2 is less than or equal to 3. And then I guess we could say 10 is greater than or equal to 0. But the idea is that for the ones that have the lines underneath, they could be equal, right? Next, we're going to just compare what we know. Just do some practice problems, and then I'll let you guys finish the sheet on your own. Again, a very important hint right here. Some of these might end up being absolute value, or some of them might have exponents or scientific notation, and it's really important to figure out what those numbers are first before you even start comparing your numbers. So, square root of 99, we talked about those weird square roots before, so we can get into that in a second, but I do want to talk about 3 squared. I know what 3 squared is, right? 3 times 3 equals 9. So I'm really comparing the square root of 99 to the square root of 9. What we talked about with our square roots is that the square root of 99 is not a perfect square. So the square root is not going to be a whole number, but I do know it's between 9 and 10. So this number is between 9 and 10. It's probably a little closer to 10. And this number is 9, which means a number between 9 and 10 is definitely going to be greater than 9. Next, we'll hop down over here. Again, it gives you some weird square root thing, simplify that first before you can before you actually start comparing. So the square root of 4 is 2, and because the negative sign's in front, this is really negative 2, and negative 2 is definitely smaller than negative 1.05. Next I've got pi, and a number that looks like pi, but remember, pi is a decimal that goes on forever and does not repeat. It ends up being 3.1415, whatever, which means because it has those little extra parts in the thousands and 10,000s, it's going to be bigger than 3.14. Let's see if we can get all of them to be greater than. Again, with an exponent, anything to the 0 power is 1, so this is really saying 1 and 4/3. We might change this into a mixed number. 4/3 is really 1 and 1/3, and 1 and 1/3 is definitely greater than 1. And last but not least, we've got our percent, so we've got our scientific notation. Just for completionist's sake, let's change this into a decimal, so I'll move it 2 times to the left and get 0.75. With my scientific notation, remember my exponent lets me know where I'm moving it, so I'll move it 2 places to the right, and this is really 750, and 750 is a lot bigger than 0.75. So there are a couple problems here that I want you guys to work on your own, and we'll go over this independent practice when we get back in class.